Hello and welcome to our video on thunderstorms. Specifically, we are talking about thunderstorm avoidance. And in this video, we're going to talk about things that you can do while you're flying, how to avoid thunderstorms and resources available to you. And a couple of things you should know. Number one is how to use airborne weather radar, or actually how to interpret radar, any kind of radar. And then also, you should know about thunderstorm characteristics because that determines the severity of the storm frequently. So first off, radar. Radar comes in a lot of different flavors. There's airborne weather radar, which is X-band radar. That is typically in the nose of an airplane. Sometimes it is carried under a pod on the wing, but that has certain limitations. We'll talk a little bit about that. Also, you can get weather information concerning radar from data link, which is either FISB, which is part of the ATSC system, or if you have a subscription, you can get XM satellite weather. Also, storm scopes are old technology that are still being used. And then finally, you can always fall back on air traffic control for radar updates. So airborne weather radar, of course, should be used for thunderstorm avoidance. They are X-band radars, and they are used well when flying around thunderstorms in close proximity to storms. Looking at thunderstorms at a great distance, typically the beam width is so wide, and the power and the curvature of the Earth is overshooting a lot of the tops, that you won't really see much detail when looking at the 200-mile range or 150-mile range. Typically, when you use airborne weather radar, you're looking at the short ranges, and we're talking at 50 miles or 75 miles. So they're good for using for short range, but bad at long range. Also, you should remember the problems that we talked about with attenuation. Specifically, don't ever fly towards a radar shadow. You should know what shadowing means. And also, in previous videos, we talked about tilt management. Remember that as you approach a thunderstorm at high altitude, you have to progressively tilt down to see details in the storm. If you're flying at low altitudes, you have to progressively tilt higher as you approach a thunderstorm. And at mid altitudes, typically the radar beam is pointed straight ahead of the radar. A rule of thumb is typically put the radar range, the range for the radar, at about half of your true airspeed. Data link, whether it be FISB or if it is XM satellite weather, is invaluable for strategic planning. But remember that the latency issues and the update rates may be slow. Remember, thunderstorms change very quickly, very fast. Lifetimes of thunderstorms are on the order of 30 minutes. And update rates with satellite or with FISB can be up to 20 to 30 minutes. So thunderstorms can grow and fall apart in that period of time. So you should use XM or FISB for strategic planning, meaning looking ahead down the road and not specifically to circumnavigate individual cells because they'll change in that period of time. Storm scope is an old technology that's still available, and what it does, it tells you the direction and basically the range of lightning. And where there's lightning, more than likely there's a thunderstorm. So that helps you identify where there are storms and whether those storms are producing lightning. Air traffic control can also give you guidance as far as thunderstorms. Remember that they use WARP, which displays the National Weather Service radar on top of their radar scope, all the echoes. So, of course, with CRM or crew resource management, you should make available all resources that are at your disposal, both in the cockpit and also on the ground. So talk to air traffic control. Make sure you know the terminology, because they will report thunderstorms or precipitation echoes as either light, moderate, heavy, or extreme. And typically when you're looking at storms, you're looking at heavy or extreme. Moderate would be more like rain showers, and light is just kind of, well, light precipitation. So that's radar. We'll get into thunderstorm characteristics. Of course, you need to know about how tall the storms are, some way of finding that out. Also, the reflectivity gradient tells you how strong certain parts of the storm are. And then, of course, we covered thunderstorm classification or types, and then we'll talk a little bit about movement. So thunderstorm height, of course, depends upon the instability of the atmosphere. So the more unstable, the stronger the updraft, and typically the taller the thunderstorm. So tall thunderstorms, of course, imply strong updrafts. And one measure that we said of instability, one way of measuring that is CAPE. Also, thunderstorm height, typically thunderstorms top out at the tropopause because the tropopause is a very stable layer. So if there are storms going above the tropopause, you have overshooting tops and very vigorous storms. One way of finding the tropopause is by looking at the high-level significant weather prognostic chart. It gives you tropopause heights for various regions, or you can look at soundings. As far as reflectivity gradients, generally speaking, where there is a stronger gradient, meaning a bigger change, a very rapid change in color over a short distance, typically you have a more intense storm, and that's where you find stronger updrafts and stronger downdrafts. If the gradient is weaker, where the change in color occurs over a great distance, then more than likely the storm in that area tends to be weaker, and it's generally safer to fly through those regions. The thunderstorm type also determines the type of hazard. As you know, with supercells, you tend to have tornadoes and large hail, whereas with squall lines, you tend to have more straight line winds, strong straight line winds. And single cell thunderstorms typically, unless they're pulsed, they're usually not severe. So that gives you an idea of the type of storms. Of course, you want to give supercells a wide berth as well as squall lines. But air mass type thunderstorms you might be able to fly a little bit closer to. And then finally, it's really useful to know which way the storms are moving, and generally most thunderstorms move the speed and direction of the 700 millibar winds, which is 10,000 feet. Faster moving thunderstorms, of course, tend to be more dangerous because they put down a much stronger downdraft, or a strong downdraft and very strong straight line winds. And then, of course, if you see a thunderstorm that moves to the right of the environmental winds, then you know it is a severe thunderstorm. Typically, supercells do that, and they can be very dangerous and also unpredictable. So that gives you some things to consider when you're thinking about flying around storms. Gives you things to help you interpret the type of storms and the direction of movement and how tall and vigorous the storms are.